Welcome back to the channel. So today in this video we are going to discuss yet another concept regarding set theory. This concept is called Venn diagram. So what exactly are Venn diagrams? Venn diagrams are the diagrams that are used to represent the sets, relation between the sets, and operation performed on them in a pictorial way. So whenever we represent sets or relation between the sets, we use Venn diagrams. So Venn diagram is actually the representation of sets in a diagrammatical way. So these diagrams are also known as set diagrams or logic diagrams. So we use Venn diagrams to represent sets, relation between the sets like A union B and A intersection B. These are the relations which we'll be discussing in upcoming videos. These relations can also be represented diagrammatically using a Venn diagram. Let us try to understand how Venn diagrams work. First of all, we use a rectangle to represent a universal set. So we know what a universal set is. So here we are using a rectangle to represent this very set. Now suppose we have a set A, which is the subset of this universal set. So that set will be represented in the form of a circle, which will be inside the rectangular region, which means that this set A will obviously be the subset of U. So this is a simple example. Now let us take some more examples to understand this concept. So let us consider a universal set having elements 1, 2 up to 8. Here again we are using a rectangle to represent this universal set, and we have enlisted all the elements within this rectangular region. Now let us suppose we have another set A whose elements are 4 and 5. Clearly we can observe that set A is a subset of U. So here again the same information is conveyed by Venn diagram as before. Now let us take another example to understand this concept. Here again we are having another set U, which is a universal set again having elements 1, 2 up to 10. So here again we are using rectangle to represent a universal set, and we have enlisted all the elements within this rectangular region. Now suppose we have two more sets, set A and set B. Here set A is having elements 9 and 10. You can see that set A is having only two elements 9 and 10. And set B is having elements 4, 5, 9 and 10. Here you can see set B, it is having elements 4, 5, 9 as well as 10, because you can see that these four elements are coming within the circular region of B. So here clearly we can see that A is a subset of U, B again is a subset of U. So here you can say that A is a subset of U and B is also a subset of U, and thus we can also observe that A is also a subset of B. So I hope this makes sense. Do subscribe the channel and thanks for watching.